Math team, linear congruences, we're looking at section 4.4. We're looking at problem number 5. And problem number 5, this is something that I wasn't able to go over with you directly. It's the last example in section 4.4. They're saying, look, let's say you have 17x is congruent to 3 mod 2 times 3 times 5 times 7. They're saying that you can solve for this by solving a system of equations. By solving 7x is congruent to 3 mod 2. Also solving 17x is congruent to 3 mod 3. 17x is congruent to 3 mod 5. And then last, 17x is congruent to 3 mod 7. You might wonder, why can we do this? Look, the 2 times 3 times 5 times 7, gosh, that's going to be a rather large number. 2 times 5 is 10, 7 times 3 is 21, that's 210. Whatever answer we get here, we would expect that we'd be getting the same remainders if we had mod 2, mod 3, mod 5, and mod 7. So that's why we can set this up. But let's go ahead and just quickly solve here. Mod 2, hey, 17 actually is a remainder of just 1 itself, so that's like 1x. 3, when you, divide by 2, you have a remainder of 1. Or here's another cool way to do it. You could just subtract a 2 from 3 and get the same thing. You come over here, many different ways you can solve 17x congruent to 3 mod 3. Tell you what, this might surprise you, but I'm going to double both sides. You can think, why in the world are you doing that? Well, because 34 is 1 step bigger than 33. We'd have a remainder of 1. That would be an x. And 6, of course, when you divide that by 3, you get a 0. Look at that. That's kind of nice. Hey, that's kind of clever when you think about it. You know what? Here's an alternate way we can solve this mod 5 congruence. Let's double both sides. It's not the only way you can do it, but you can think, wait a minute, hold on a second. 34 has a remainder of 4 when you divide by 5. Yeah, but 4 is equivalent to negative 1. Look at that. 4 is congruent to negative 1 in mod 5. Yeah, because 4 minus negative 1 is divisible by 5. Wow. And then 6, of course, you have a remainder of 1. You don't have to solve it this way, but you certainly could. How about I multiply both sides by a negative 1? You can always multiply both sides by whatever you'd like. How about we add a 5 right here, and we're back to a 4, just talking about what we had. Hey, look at that. Kind of a slick way that you can solve. Hey, I like that method. How about we do it again? Double over here with 17. Maybe we get 34. Maybe that's going to help us out. I think it will. Thought I saw something really cool, because 34 is 1 step below 35. You know what? That's a remainder of negative 1. Look at that. That's kind of cool. Here, of course, 6 is just 6 in mod 7. How about we multiply both sides by a negative 1? And then what is negative 6 equivalent to? Well, you could just add a 7 if you'd like. Look at that. Before too long, you've got, solutions to all of these. So this is going to be what I'm going to call method 1 to solving this kind of a setup. Take a look at this first equation right here. This is going to be very clearly x is equal to 1 plus 2t. You're saying that you'd have x is equal to 1, and of course any multiple of 2 added to that, or if t would be negative, you could subtract it. You'd have all of your solutions. But wow, take a look at this. We could go ahead and substitute that in here and say, instead of having an x, let's write 1 plus 2t. Think, wow, why are you doing that? Well, tell you what, I'm going to subtract a 1 from both sides. Look at that. By the way, if you don't like the looks of the negative 1 here, how about we add a 3 to it? and we'd see that that's equivalent to a 2. Look at that. And then because the 2 and the 3, the greatest common divisor is just a 1, I could divide by 2 and not change my mod. Well, hey, look at that. This would indicate that we'd have t would equal 1 plus 3, some other multiple of 3. Maybe you want to write something like s, not using the same letter of t. So any multiple of 3, you add to 1, and there you go. But let's bring this back down. If x was equal to 1 plus 2t, then x would be 1 plus 2 times 1 plus 3s. And if we distribute a 2 in there, let's see, we get 2 plus 6s. Only takes you a moment to see that x is equal to 3 plus 6s. So why are you doing that? Well, now I'm going to come over here to my next system and say, instead of having an x, let's write that as 6 plus 3s. And see where we can go with that. Well, I hope you can see you can subtract a 3 from both sides. Got to put some fangs on this s so we don't confuse that for a 1. I mean, confuse it for a 5, especially with mod 5. Look at the 6 here. My goodness, 6 is congruent to a 1. So s is equal or congruent to 1 mod 5. What are we really saying then? S is equal to really 1 plus some multiple of 5. So maybe you'd like to call it 5r. Just use a different letter. But look, x, if we recopied it, x was 3 plus 6s. And that means my s here is 1 plus 5r. And I can distribute that 6. And 6 times 5 is 30. We got 30r. So wow, x is now 9 plus 30r. Wow. You might wonder where we're going now. I bet you have a guess. You're going to take that x and plug it into our final equation. We've got this system. Look at this. So we've got 9 plus 30r is congruent to 1 mod 7. And now we're going to go ahead and try to solve. Now, if I subtract a 9 from both sides, of course, we'd have 30r is congruent to negative 8. And from here, we can think, well, gosh, is there anything we can do? Well, look, 30 and 7 are relatively prime. The greatest common divisor between 30 and 7 is a 1. That's what relatively prime means. 1's the biggest number I could divide out of them. So that means I can divide by 2 and not change my mod. Choosing to divide by 2, I hope it's pretty obvious, because you'd say, wow, look at 15. 15 is 1 step bigger than 14. So you'd have a remainder of just a 1. So r would be congruent to negative 4 mod 7. What is negative 4? How about we just add a 7 to negative 4 and we get 3 plus our 7k. Well, 7, yeah, we'll just call it K. I had to choose one other letter here. I just decided to pick it. Was a bit scared for a second. I already had K, but it looks like I don't. Well, look, your x is equal to 9 plus 30r. And you have 30 times 3 plus 7k. That's what your r is. Well, let's clean it up. 30 times 3 is 90. 30 times 7 is 210k. So what do we have? Our final answer, 99 plus 210k. This right here is our solution.